Hi, in last class I am already about a differential amplifier. In today's class I am going to teach about a CMRR ratio. It is also called as a common mode rejection ratio. Why we are choosing this common mode rejection ratio? It is one of the features of a differential amplifier. Okay, what is meant by CMR ratio? We are going to learn. Here, this is the topic which is covered in the unit 1. Okay, so if value of the CMR ratio is high, it is a good differential amplifier for designing of an operational amplifier. Okay, for this we are going to derive the equations for the CMRR ratio. Okay, so what is meant by CMRR ratio? Okay, the differential amplifier rejects, the ability of a differential amplifier rejects a common mode signal. Rejects a common mode signal. It is an CMRR ratio. Okay, the ability of an differential amplifier to reject a common mode signal is expressed by a ratio called common mode rejection ratio. Okay, CMRR. We can simply call it as a CMRR ratio. Okay, the ability of a differential amplifier rejects a common mode signal. It is called as a CMRR ratio. Okay, and is defined as CMRR ratio is defined as the ratio of the voltage, differential gain voltage, unto the ratio of the common mode voltage gain. Okay, CMR ratio is defined as CMRR. CMRR means common mode rejection ratio. It is defined as the ratio of the differential voltage gain AD to common mode voltage gain AC. Okay, in yesterday's class you are derived already what is meant by differential voltage gain AD and also common mode voltage gain AC. Okay, it is a ratio between differential voltage gain to the common mode voltage gain. It is defined as a CMRR ratio. What is meant by CMR? It is one of the feature of a differential amplifier. If CMR ratio is high, then if CMRR value is high, then it is a good differential amplifier for designing of an operational amplifier block. Okay, so based upon the value of the CMR ratio, we are going to choose that particular differential amplifier for designing of an operational amplifier. So what is meant by CMRR ratio? It is a ratio between differential voltage gain to the common mode voltage gain. It is an CMRR ratio and it is also called as an common mode rejection ratio. As the name indicates that common mode operation rejection. Okay, so simply we are calling like this CMRR. Okay, common mode rejection. We have two operations in differential amplifiers. What are the operations? One is the differential voltage gain, differential mode operation, and another one is a common mode operation. In this, it allows only differential mode operation and it rejects common mode operation. So it is called as a common mode rejection rate. It allows only differential voltage and it rejects common mode operation. It allows only differential mode operation and rejects the common mode operation. Simply we can call it as an common mode rejection ratio. Okay, for the designing of a differential amplifier, we can choose only differential mode operation is high and the common mode operation is very low. So it is a good differential amplifier for designing of an operational amplifier. So the common mode rejection amplifier is defined as the ratio between differential voltage gain unto the common mode voltage gain. Okay, simply we can write the CMRR as an rho. We can by using rho equals to, it is the ratio between AD. AD means what? Differential voltage gain to the ratio of a common mode voltage gain. It is the ratio of a differential voltage gain to the common mode voltage gain. In yesterday's class, We are derived already what is meant by differential voltage gain, what is meant by common mode voltage gain. Okay. So, what is the output? The output voltage in terms of an we can derive this CMR ratio in terms of an output voltage V0. So here V0 equals to ACVD. We already derived this V0 in yesterday's class. V0 equals to ACVC plus ADVD. Okay. Okay, we are written this differential amplifier output in the form of an, we can, it is, what it is, differential amplifier output voltage. In yesterday's class, we have already derived this. Okay, we can write these output voltage in the form of an CMRR. Okay, so we can take this differential amplifier output V0 equals to ACVC. We are considering differential amplifier output voltage. Okay, V0 equals to ACVC plus ADVD. Okay, we can derive this differential amplifier output in the form of a CMRR. We can take output voltage V0 and we can express these differential amplifier output voltage in the form of a CMRR. So we are taking differential amplifier V0 as an like this. V0 equals to ACVC and plus ADVD. We can derive already this differential amplifier output in yesterday's class. So, in terms of a CMRR, we can also write like this. Okay. So, from this V0 is equals to ADVD. We can take ADVD as common. So, 1 plus here we can take ADVD as an output. So, out plus ACVC by ADVD. So, in the form, we can write V0 equals to ADVD of 1 plus, in the place of an CMR, we already know CMRR equals to rho. Rho equals to AD by AC. Okay. So, in the place of an AD by AC, we can write 1 by rho. It is only rho. So, in the place of an AD by AC by AD, we can write 1 by rho into VC by VD. It is an CMRR in the form of a differential amplifier output. Okay. So here common mode signals are greatly rejected now. From this equation, we can consider this equation as 1. From first equation, what we can get? From first equation, we can get V0 is equals to ADVD of 1 plus 1 by rho VC by VD. From first equation, this is the first equation now. So, from this, we can write V0 equals to AD into VD. Why? Because VC and VD are very small, so we can neglect that VC and the VD. Other nothing, with presence of this VD and VC, we can also write like this. V0 equals to AD into VD, and from this we can V0 equals to voltage difference VD. So in this equation, with this equation, we can know that it rejects, output voltage rejects, what it can reject? Common mode voltage signal. Common mode voltage signals. Okay. Here greatly rejection of an common mode voltage signals now. Here only it presence of a differential mode voltage signals. There is no presence of a common mode voltage signals. It shows that greatly rejection of an common mode voltage signals when we are considering differential amplifier as an output voltage. Okay. So, from this we are knowing that there is a greatly rejection of a common mode voltage signals. As the definition it satisfies, it rejects the common mode voltage signals. It rejects common mode voltage signal. CMR ratio is the ability of the differential amplifier to reject, say, common mode voltage signals is represented by a ratio called common mode rejection ratio. It is called as an CMRR. It is the ratio of a differential voltage gain to the common mode voltage gain. It is written as like this. Okay. So, I am telling once again what is meant by CMRR. It is the ratio of, it is defined as an rejection of an common mode signals and allows only differential mode voltage signals. And derive the CMRR ratio in terms of an differential amplifier. Once again, CMRR is equals to rho equals to AD by AC. From the definition, it is the ratio of an differential voltage gain to the common mode voltage gain. Okay. So, in terms of CMRR, we can write by using differential amplifier output, V0. Okay. V0 can be expressed in the form of an CMRR. So, what is the equation for an differential amplifier output voltage? From yesterday's class, V0 equals to AD VD plus AC VC. So, in the form of an CMRR, we can write AD VD taken as a common 1 plus AC VC by AD VD. So, V0 equals to AD VD of 1 plus, in place of an AC by AD, we can write like this, 1 by rho VC by VD. So, from this, V0 equals to AD VD, where VC and VD values are less. So, we can write like this, V0 equals to AD VD. From this equation, V0 equals to AD VD. V0 is proportional to VD. Okay. Here we can see the only differential amplifier, differential voltage. It is an differential mode voltage signals. Okay. This is the only differential mode voltage signals. There is no presence of a common mode voltage signals. It seems that here greatly rejection of an common mode voltage signals and allows only differential mode voltage signals. As the name suggests, common mode rejection ratio, it is the rejection of an common mode voltage signals and allows only differential mode voltage signals. Okay, this is an output of an CMRR ratio in the form of an differential amplifier V0. Okay, this is about in terms of an CMRR, we can write differential amplifier output V0 like this. V0 is equals to ADVD plus ACVC, and ADVD is taken out 1 plus 1 by rho VC by VD. VC and VD are very less, so we can consider V0 equals to ADVD. From this we can write like this. V0 is proportional to VD. Here we can see the greatly rejection of an common mode voltage signals and allows only differential voltage signals. Okay, this is about CMRR ratio. I am telling once again the definition of an CMRR ratio. Common mode rejection ratio means the ability of the differential amplifier to reject a common mode signal is expressed by a ratio. It's called common mode rejection ratio. Okay. CMRR ratio is defined as a ratio between differential voltage gain AD to common mode voltage gain AC. Okay, it is expressed in the form of an AD by AC, and this is the derivation of an output voltage of an differential amplifier output voltage of differential amplifier. In yesterday's class, we are derived this already differential amplifier. Okay, you already know what is meant by differential amplifier. What are the operations of an differential amplifier now? What are the operations? Differential mode voltage gain operations and the common mode operations. Okay, from this it allows only, CMRR ratio means what? It allows only differential mode operation and rejects the common mode operation. We derive that we can get only differential mode operation and rejects the common mode operation. From this equation, we are derive the CMRR ratio by using differential amplifier output. Okay, so this is about CMRR ratio. Okay, I am going to tell the problem based on this differential amplifier for the given input signals. Okay, so I am going to teach the problems based on differential amplifier. This is the next topic I am going to tell. Okay, problems. This is the problem 1. Okay, determine what is the problem. Determine the output voltage of a differential amplifier for the input voltages of 300 microvolts and the 200 microvolts. The differential gain of the amplifier is 5000 and the value of the CMRR is first one 100 and second one is 10 power 5. Okay, what is given here? What are the values given here? We have to find out V naught. This is the solution. This is a solution I am giving. Determine output voltage. We have to determine the output voltage. V naught equals to how much? Okay, and inputs are given. What are the inputs? Here the inputs. V1 equals to 300 microvolts and V2 equals to 200 microvolts. Okay, the differential gain of the amplifier is 5000. What is the differential gain? Differential gain is represented in the form of an AD. AD equals to 5000 and the value of the CMRR is in the first 100 and in second 10 power 5. The value of the CMRR one value is 100 and CMRR and second value is 10 power 5. We are going to solve the output voltage of the differential amplifier. Okay, next is when CMRR equals to 10 power 5. We can substitute these. V naught equals to AD means 5000 here 5000 into 100 of 1 plus 1 by rho means 10 power 5 into 250 by 100. Only I can simplify these only. I can substitute these 10 power 5 in this formula. Okay, in this formula V naught I can substitute these. I am substitute these 10 power 5 in this. Okay, so here we can get an V naught equals to 0.5 volts from this. Okay, here CMRR is very high, so there is rejection of common mode signals here. Okay, here CMRR value is 100, so there is effect of a common mode signals. When CMRR is very low, there is an effect of a common mode signals. Here CMRR is 10 power 5 compared to here it is very high, so CMRR is very high, so there is rejection of a common mode signals. So there is here CMRR is 100, so there is allows only a common mode voltage signals. Okay, here CMRR ratio is very high, so there is a greatly rejection of a common mode signals here. Okay, so in the designing purpose of a differential amplifier, one can choose the CMRR ratio is value is very high. So when CMR ratio value is very high, so it is a good differential amplifier for designing of various operational amplifiers for the designing of various applications based upon our requirements. So this is about an CMR ratio. By considering the CMR ratio, when CMR ratio is very high, it is a good differential amplifier for designing purpose. So one of the feature of an differential amplifier is when there is a high CMR ratio, it is a good differential amplifier. It is one of the features of an differential amplifier for designing of an differential amplifier block. So it is about a differential amplifier. I am going to teach the later topic in next video. So this is about a CMR ratio topic, which is also called as a common mode rejection ratio. Thank you. Okay, next is when CMRR equals to 10 power 5. We can substitute these. V0 equals to AD means 5000 here 5000 into 100 of 1 plus 1 by rho means 10 power 5 into 250 by 100. Only I can simplify these only. I can substitute these 10 power 5 in this formula. Okay, in this formula V0 I can substitute these and substitute these 10 power 5 in this. Okay, so here we can get an V0 equals to 0.5 volts from this. Okay, here CMRR is very high, so there is rejection of mode signals here. Okay. Here CMRR ratio, CMRR value is 100. So there is effect of a common mode signals. When CMRR is very low, there is a effect of a common mode signals. Here CMRR is 10 power 5. Compared to here, it is very high. So CMRR is very high. So there is rejection of a common mode signals. So there is